In class 7 of a school, there are two divisions, A and B. The average weight of students in class 7A is 50 kilograms and that of students in class 7B is 60 kilograms. Each division has 30 students, and remember, there are only two divisions in class 7. With this data provided, we have been asked to find the average weight of class 7. Yes, what will be the average when the students from both these divisions are combined? The concept of average is still the same. It will be the total weight of all students in class 7 divided by the total number of students in class 7. Total weight divided by the number of samples. Now, what will be the total weight of all the students in class 7? Will it be 50 kilograms plus 60 kilograms? Of course not. We are talking about the sum of weights of all students in class 7. So the total weight of students in class 7 will equal the total weight of students in class 7A plus the total weight of students in class 7B. This will give us the total weight. And what about the total number of students in class 7? It will equal the number of students in class 7A plus the number of students in class 7B. Now this is the important part. What is the total weight of students in class 7A? It will be the average weight multiplied by the number of students. Remember, A is equal to S over N, hence S will equal A times N. So that will equal 50 times 30, and likewise the total weight of students in 7B will equal 60 times 30. And the number of students in each of the divisions is 30. This will give us the average weight of all the students in class 7. Solving this will give us the combined average as 55 kilograms. This is the average weight of all the students in class 7. Notice that it is exactly between 50 and 60. So we didn't really need to do all this, right? We could have easily found the combined average by finding the average of the two averages. 50 plus 60 over 2 would have also given us 55 kilograms as the combined average. But will this always work? Let's take another example. This time of grade 8 in a school. Two divisions, average weights are 50 and 60, and the number of students are 20 and 40. There are only these two divisions in class 8. What will be the average of all the students in class 8? Will it be 50 plus 60 over 2 again? This is not correct, and 55 kilos would be an incorrect answer. Let's understand how. We go with the correct definition of average. Total weight of all students in class 8 divided by the total number of students in class 8. That would be this. 50 times 20 plus 60 times 40 divided by 20 plus 40. This is the sum of weights of students in 8A. This is the sum of weights of students in 8B. And this is the total number of students. Solving this will give us the average as 56.666 kilograms. That's the average weight of all the students of class 8. But wait, how come the average of averages did not work here? To understand this, let's take the two averages at the two ends of a line segment. These are the two averages in question. And let this be the center point 55. Now observe that there are 40 students in class 8B and just 20 in class 8A. Clearly, this average has more weightage. More number of students implies that this average will have more weightage. And that is why you see that the answer is closer to 60 kilograms and not 50 kilograms. It will be somewhere here. It's getting pulled towards 60 as the number of students is more in 8B. Now we go back to the class 7 problem. Why did this formula work here? It's because both divisions had the same number of students, same weightage. Only if the weightage is the same can we use this formula. Else we go with this one. Here's another scenario. In this example, what would be the average of class 8 if class 8A had just 5 students and class 8B had 55 students? The average weights of 8A and 8B are the same, just the number of students that have changed. What would be the average of class 8 then? Pause the video and try to find the average this time. it will equal this: 50 times 5 plus 60 times 55 divided by 5 plus 55. Solving this will give us the average as 59.1666 kilograms. And clearly, this is even more closer to 60. And why is that? Clearly because 8B has more weightage. It's 55 versus 5. This is the concept of weighted average. The combined or the weighted average depends on the weights of the individual averages. And don't worry, there are better and faster ways of finding the weighted averages. We will cover many more examples over the next few lessons. There are two levels in an exam, Level 1 and Level 2. A student will pass the exam if she scores an average of 75% or more. If her overall average is 75% or more, she passes the exam, else she fails. With this data given, did she pass the exam? Pause the video and go through the problem well. We have been asked if she passed the exam or not. In the first level, she scored 85%, and in the second, she managed 50%. Maximum marks tell us that the first level was out of 80 marks and the second out of 20 marks. We need to find out her overall or resultant percentage. We need to find the resultant average percentage. And how can we find that? With pure logic, we can say that her overall average percentage will equal the total marks she had scored in both the exams divided by the maximum marks of both exams together. The marks she scored in Level 1 will be 85% of 80 and the marks she scored in Level 2 will be 50% of 20. Remember, if it's percentage here, it has to be maximum marks here, else we will not be able to find her individual scores. And this is divided by the total maximum marks. That will equal 80 plus 20. This will give us her overall percentage. Now don't write this as 85 over 100 and this as 50 over 100. That will just complicate the calculations. As both quantities have percent, we don't write them as something over 100. 85 times 80 is 6,800 and 50 times 20 is 1,000. The sum is 7,800. And in the denominator, we have 100. This gives us the answer as 78%. That's her overall percentage. So does she pass the exam? The condition stated is that if she scores 75% or more, she has passed. And 78% is clearly greater than 75%. So yes, she has passed the exam. This was also a weighted average problem asked differently. Even though she fared poorly in the second level, she passed because the second level had lesser weightage. She performed well in the level that mattered more and had more weightage. In this problem, we are told that the shopkeeper sells 1/4 of his chocolates at 40 rupees each and 2/3 at 30 rupees each. Now listen to the question carefully. At what price should the remaining chocolates be sold such that the average selling price of all the chocolates is 32 rupees each? This is quite interesting. We haven't been told the number of chocolates the shopkeeper has, but we know that she has divided them into 3 categories. 1/4 of them at 40 rupees, 2/3 of them at 30 rupees, and the remaining are sold at some price such that the overall selling price is 32 rupees. So how do we approach this problem? As we don't know the number of chocolates the shopkeeper had, let's assume she had X chocolates. Now it will get easier. If the total chocolates the shopkeeper had is X, then what will be the number of chocolates she sold at 40 rupees? 1/4 at 40 rupees. So it will be X over 4. She sold X over 4 chocolates at 40 rupees. Then how many chocolates did she sell at 30 rupees? 2/3 will be 2x over 3. And we don't know at what price she sold the remaining chocolates. Let's call that number Y. But wait, how many chocolates remain? Out of the total of X chocolates, X over 4 and 2x over 3 was sold. So the number of chocolates that remain will be x minus x over 4 minus 2x over 3. We have the remaining number of chocolates as x over 12. Now with this data given, can you write the average price in terms of x and y? It's easy. It will be the total selling price divided by the number of chocolates. Try it out. This is how it will look. This is the average price of all the chocolates together. 40 times x over 4 is the total selling price of the first set of chocolates. 30 times 2x over 3 is the selling price of the second set. And y times x over 12 is the selling price of the third. And this is the total number of chocolates, which will obviously add up to x. In the question, we have been given the average selling price as 32. So this entire thing will equal 32 rupees. The x from the numerator and the denominator will cancel out, and we will get the value of y. That will be the price at which the remaining chocolates will be sold. But this was not the best way to solve this problem. It's time-consuming as there are fractions involved. The moment you see something like this, you should realize that x will cancel from the numerator and the denominator. And the moment you realize that a quantity is going to get cancelled, you should assume an appropriate value for that quantity. So we can assume a value for x to get rid of the fractions. The denominators are 4, 3 and 12. X should be the LCM of these three numbers. The LCM of 4, 3 and 12 is 12. So we can assume that the shopkeeper has 12 chocolates in all. These are the three categories. She sells a few at 40 rupees, a few at 30 rupees, and the remaining at y rupees. She sells 1/4 of the chocolates at 40 rupees. 1/4 of 12 is 3. She sells 2/3 at 30 rupees. 2 over 3 times 12 is 8. And she sells the remaining at y rupees. Out of 12, 3 and 8 are sold. 1 remains. Remember, 12 chocolates are just an assumption. With this assumption, this will be the average price of all the chocolates. This is the total price of all the chocolates together, and this is the total number of chocolates. The average price is given to us as 32 rupees. Now you tell me, which method is easier to solve for y? Clearly, it's this one. We get the value of y as 24. She sold the remaining number of chocolates at 24 rupees each. Don't forget, we still don't know the number of chocolates she sold. 12 was just an assumption to make our life easier. So that's what test prep exams are all about. Choosing the best and the fastest way to arrive at an answer. Here's a weighted average problem for you. 13,650 pens was sold at an average price of 15 rupees and 15,600 pens was sold at an average price of 45 rupees. We have been asked for the average price of all these pens taken together. It's a typical weighted average problem. What will be the resultant average price? It will be the total cost of all the pens together divided by the total number of pens. The total cost of the first set of pens will be 15 times 13,650 and the total cost of the second set of pens will be 45 times 15,600. And for the total number of pens, we simply add these two. This will be the resultant average price of all these pens taken together. I want you to pause the video and find the combined average here. Clearly, it would have taken you a lot of time to solve this. If you actually solve this huge fraction, you just wasted a lot of time. Though this will give you the correct answer, it's a very slow approach. How else can we tackle this problem? To understand the answer, let's look at a very simple example. We have seen this example before and we will go through it again very quickly. But if you haven't watched this detailed tutorial, I recommend you do so. It will really help. Okay, so two divisions in class 8, 8A and 8B. We have the respective average weights and respective number of students in each division. What will be the average weight of class 8? With the data given, we get the class 8 average weight as 56.666 kilograms. This is the overall average weight of class 8. Now let me modify the question slightly. What if I told you that the number of students in division A and B were 10 and 20 respectively? The average weights are the same, but the number of students are 10 and 20. What will be the overall average in this case? It will equal this: 50 times 10 plus 60 times 20 divided by 10 plus 20. Total weight divided by the number of students. This is 500 plus 1200 divided by 30. 1700 divided by 30 will give us the answer as 56.666 kilograms. We got the same average again. Okay, wait. Let me give you another scenario. What if the number of students in division A and B were 1 and 2 respectively? What would be the overall average then? It would equal this ratio: total weight of all the students divided by the total number of students. The numerator will be 50 plus 120 or 170, and the denominator is 3. 170 over 3 will equal 56.666 kilograms again. Wait, what's happening? Why isn't the average changing? The answer is simple. Just notice that the ratio of weights in every case is the same. By weights, I do not mean the average weights. Here the weights are 20 and 40, 10 and 20, and 1 and 2. They are the weights of these two parameters. In each case, the ratio is 1 to 2. So this tells us something extremely important. We don't really need the individual weights. All we need is the ratio of the weights. If the individual weights were W1 and W2, then just the ratio W1 to W2 is enough to find the overall average. So in this particular problem, when we saw 20 and 40, we could have written the ratio as 1 to 2 and then found the overall average. It just makes our calculation simpler. If we have A1, A2 and the ratio W1 to W2, we can easily get the overall average in the same way. But do you know why? It's simple. Just assume the weights are W1K and W2K. If the averages are A1 and A2, then the overall average will look like this. Clearly, the constant K gets cancelled from the numerator and the denominator. What matters is just the ratio W1 to W2. And now, let's get back to the original question. Can you think of a better way to solve this? Here the two averages are 15 and 45. And these are the weights of those averages. So all we really need is the ratio of the two weights. The simplest form of this ratio is 7 to 8. So instead of this, the resultant average can be written like this. Isn't it obvious as to which one is easier to solve? It's this one. Solving this should give us the overall average as 31 rupees. That's the average price of all these pens taken together. So remember, if we have A1, A2 and the ratio of the weights W1 to W2, we can easily find the resultant average. Let's quickly review what we have learned in weighted averages. If we have two averages A1 and A2 and their respective weights N1 and N2, we can easily find the resultant average AR. And what is the formula to find AR? It is A1 N1 plus A2 N2 divided by N1 plus N2. Do we always have 5 quantities in the picture? Are we generally given 4 and asked to find the fifth one? In the previous lesson, we arrived at a very important conclusion. More than N1 and N2 individually, it is the ratio of N1 to N2 that is more important. So these are the 4 important quantities: A1, A2, AR, and the ratio of N1 to N2. We will be given 3 and asked to find the fourth one. We have seen examples in which A1, A2 and this ratio were given and we had to find AR. But what if we were given these 3 quantities and asked to find this ratio? Will this formula work? Let's see. Look at this example. just 2 divisions in Class 8. And the average weights of students in 8A and 8B are 50 and 60 kilograms respectively. And the overall average of Class 8 is given as 58 kilograms. We are asked to find the ratio of N1 to N2. What is this ratio? It is the ratio of the number of students in Class 8A to the number of students in Class 8B. Now let's substitute these values onto our resultant average formula. We have been given the resultant average of Class 8 as 58 kilograms. And we have been given A1 as 50 kilograms and A2 as 60 kilograms. And we don't have N1 and N2. Is this enough to find the ratio N1 to N2? Let's give it a try. Transposing this to the left-hand side, we get this. To get the ratio N1 to N2, let's keep N1 on the left-hand side and N2 on the right. We get 58N1 minus 50N1 on the left. That will be 8N1. And we get 60N2 minus 58N2 on the right. That will equal 2N2. Now we can easily find the ratio. Transposing N2 to the left and 8 to the right, we get N1 over N2 as 2 over 8. And that will equal 1 over 4. That's the ratio of the number of students in Class 8A to the number of students in Class 8B. If there's 1 student in 8A, there will be 4 in 8B. If there are 10 students in 8A, there will be 40 in 8B, and so on and so forth. But now I'm going to give you some bad news. This was just waste of time. The answer is correct, but it's a very slow process. So what's the fastest way to find N1 over N2? Looking at the data of this problem, it can directly be written as 60 minus 58 over 58 minus 50. That's 2 over 8 or 1 over 4. That's it. This took us less than 5 seconds. We didn't really need to do all this. I know what you're thinking. How did we get this? Is it really that easy? This part is phenomenally important for your test prep exams. We understand this part in the next lesson.